You usually don't think twice about the cables behind your desk. But today, we're taking you on a deep dive into the hidden engineering of high-end AV equipment.
Right, yeah.
The target is the DVIGear DVI-2830-AOC DisplayPort cable. It's 30 meters long, and it costs exactly $460.
Wow.
Yeah. Okay, let's unpack this, because you're likely wondering how any cable justifies the cost of a new television.
Well, to get there, you really have to stop thinking of this as just a wire. I mean, it's a 32.4 gigabit per second data pipeline.
Which is huge.
Exactly. We're talking about pushing 8K resolution video and 30 hertz across, 100 feet without a single dropped frame.
Which is where the physics of standard copper completely break down.
Oh, absolutely. Pushing that much bandwidth over that distance on copper just results in massive signal attenuation. You end up with a blank screen.
Right. Nobody wants that. So looking at the spec sheet, they solved this by splitting the difference. It's almost like the hybrid car of cables.
Oh, I like that analogy.
Yeah, you've got 4 glass optical fibers and 6 copper wires inside one jacket. It's essentially a high-speed rail line for the heavy freight, the video.
Right.
And that's built right next to a standard 2-lane road for the administrative traffic.
Yeah, and that high-speed rail line is crucial. The glass fibers use light to transmit the main video payload.
Okay.
And what's fascinating here is that by moving the high bandwidth data to optics, you completely bypass the electrical resistance.
The resistance that degrades copper signals over distance.
Exactly. Plus, the glass is inherently immune to electromagnetic interference, or EMI.
Okay, but wait. If the goal is to avoid electromagnetic interference, why put 6 copper wires right back into the same cable?
That's a really good question.
I mean, aren't they vulnerable to the exact same interference they're trying to avoid?
They are, yeah, but those copper wires aren't carrying the 8K video. They're handling the low bandwidth bidirectional communication.
Like the EDD and HDCP handshakes.
Precisely. Converting those very precise two-way timing handshakes into an optical signal and back again introduces complex latency issues.
Ah, I see.
Yeah, keeping them on copper is simply more reliable. And since it's just administrative chatter, minor signal degradation over 100 feet isn't a showstopper.
Got it. Well, here's where it gets really interesting. I'm sort of hung up on the optics.
Okay, lay it on me.
If this thing is shooting literal lasers down 100 feet of glass, where is it pulling the voltage from? I mean, there's no external power brick on this schematic.
Nope, there isn't. It relies on an ultra-low power design.
Really?
Yeah. The internal optical transmitters draw less than 0.43 watts.
Wait, really? Less than half a watt?
Yeah, it pulls that minuscule amount of juice directly from the DisplayPort source device itself.
That is wild. So it's drawing practically no power to fire these lasers, which is great, but that brings up a massive physical problem.
Oh, the durability.
Right. You now have incredibly fragile glass optics carrying light inside a cable that stagehands are going to be stepping on, or integrators will be, yanking through commercial walls.
Which dictates the aggressive physical engineering. The specs boast 500 newtons of crush resistance.
Wow.
Yeah, which is basically a heavy AV cart rolling directly over it.
Oh.
To achieve that, they construct internal armoring that shields the glass strands from compression.
But without making the whole assembly rigid, I'm guessing.
Exactly. Hence the 35mm bend radius. It has to bend around tight corners in a conduit without snapping the glass inside.
That makes total sense.
And speaking of conduit, it's plenum rated for commercial HVAC spaces. But the real engineering trick is the connector itself.
Oh, right, the detachable ends.
Yes. The core of the cable terminates in a mini DisplayPort, but it includes these detachable full-size DisplayPort docking connectors.
So an installer can thread the tiny mini DP end through a small hole in the drywall and then just snap the full-size connector over it once it's on the other side.
Yeah, it solves a massive headache on site.
That is brilliant. So what does this all mean? We aren't just looking at a cable.
No, not at all.
We're looking at a self-powered, crush-resistant, high-speed optical bridge designed to survive the realities of professional installations.
If we connect this to the bigger picture, as our screens demand exponentially more data, from 4K to 8K and beyond, the basic physics of standard copper wire have maxed out.
Right.
We are entering an era where cables are being forced to become active, complex technological devices themselves.
Behind the desk, it's basically becoming a network of tiny computers and lasers.
Exactly right.
Which leaves you the final thought to ponder. With the displays rapidly pushing 8K and cables now housing their own microscopic optical transmitters, how long until the traditional all-copper cables in your own home become completely extinct?